Well, as I was saying, when I was working as a DevOps, I started learning the tools and technologies at first, and it was all right. But more I got exposed, I started asking these questions: how we got there? Like, we have the system, we have some problems we are solving. It's all fun, but why we are solving these problems at first place? Like, couldn't we actually prevent them? And then I realized that if I am challenging this problem and I understand what caused them, that's not going to answer, because I am at the end. I am already seeing the system is already up and running with some problems and issues. So I need to go all the way to the beginning. And that's actually how this presentation, happened. I tried to actually come up with something a little bit also funnier at the beginning. So idea is, well, you want to start designing a system, and there is so much out there, and you already know this, like the infrastructure, the security, the front end, the back end, the data, the architectures. But how are we going to have these things put together? Like, how we can start with this? So I came up with this idea. Choose one thing kind of quite well known, which you have never actually done it from scratch, like a system, maybe URL shortener, for instance, service as a service, and then try to replicate the system. It already exists. You can use it like a tiny URL, I guess, out there, and some other variations, and then try to build this system. And at first, have everything on like a whiteboard, and then put some couple components there, which will represent the things that it must be there. So when you look at this now, you see the client, the server, the database. It's kind of funny, but system is already done, because that's how it's going to be at the end. In an abstract way, that's what you will have. So the good things now, you can talk to this system, you can ask questions, and you can see, for example, we have the database. I do not know whether is a Cassandra or what type of caching I will be using there. And that's the things I see as a problem actually we might be doing in the beginning when we are designing the system. That's too soon to make those decisions. At first, let's try to understand what we try to achieve. What we try to achieve is designing this service. Users will make requests to a server to request a shortened URL, which will be stored on the database. And later on, we should be able to get this shortened URL and then access the destination, because it's actually another website we want to go, right? So, but as I said, and as you can see, it's too much, tightly coupled. It's too monolith. It doesn't actually tell that much about what this system really built. So we started doing a little bit deep dive. Instead of having the server is just one block like that, I can say, you know what, that is too monolith. Let me have the backend, and at least I can understand there is a backend. But as soon as I actually place the backend there, it just hits me. I have a backend, and how the user is going to actually interact with the backend? Oh, I can have the API. And when you have the API now, you might be thinking about all the middlewares you can have on the API level, like authentication, authorization, rate limit. Again, I believe this is not the part you think about those. That will actually come later on, and you will have actually reason to think about them. But now you have actually the kind of like the draft, not for only this system, but for many other systems that you can use it. You have the user, you have the API, the backend, and the database. And now we are thinking that, well, I hit the database, I have the backend, but it just looked like a one block, right? And then you start asking your question, what will happen if it fails? And it will fail, like some reason that you don't know. In the future, you will get a call maybe 2 a.m. in the morning when you're on call and say, the system is not working because node is down. Okay, which is not okay. So how we can prevent it? Well, you can have one more backend. Okay, then how many number of the backend you must have? So now you are actually reasoning. You are realizing that, oh, I need to scale this up. Actually, at this point, you don't need to even say scale up. You can just say scale, because maybe scale up or scale out, scale in. You don't need to think about vertical, horizontal, or anything. You just need to have a reason to actually understand that you need to scale the system based on its needs. And then it's not that you will have one like a backend over there. You will actually have microservices, because you can have each microservice scale based on some requirements, predefined maybe some configuration, or things happens like, too many requests or stuff. So you have the microservices now, but you are now considering this system as your backend. But the problem is, you have the microservices, okay, but what they will do, why you have these microservices, what they are going to do, what they are going to serve actually. So this is the moment this draft becomes actually your system. because now we can think about a little bit more specific to the URL shortener. You know, we can have actually microservices. One will handle, for example, the retrieve, one will handle the URL shortener. Actually not, because you don't need to have each microservice, you know, handle only one specific task. You can have one microservice, handles everything, but depending on the workload, you can just scale the microservice. So it is just from a visual perspective, I actually write like this way, not to actually have one microservice for each operations. Some cases you may have to, but the key factor here is this design right now makes sense to you visually. When you look at this, okay, you are understanding, you are reasoning with it, and you can ask questions. Now, after some time, you realize that, well, I make requests to the API, the microservice handles the maybe shorten to URL, and it is sort of on the database. But is it ideal? Is it like a practical? Because I need to make so many requests, maybe there will be too many users. It will be better, I guess, to maybe, you know, cache things. So you can place a cache on a system. And here, you are not saying that, oh, this is going to be Redis. Maybe you will not use Redis. Maybe you will use another out-of-box solution on the cloud provider you are using it. So after all those things, you are going to get already excited enough, and you choose your personal or most popular AI agent and ask it to actually create some Docker Compose YAML file. And then your favorite agents actually generate this, and you are excited to use it, and you realize that it is not that much working, because the status code actually, it should not be 200. You maybe even realize that there was actually something maybe even missing on the first diagram you came up with, because when you retrieve the URL, it's not that you're going to do something additional. As soon as you hit the shorten URL, you should actually redirect it to the original site that you want to go. And you can handle this by using the status code 301 or 302, because these are two different things. One is actually about the caching and is not. And this is actually kind of things that you may miss in the beginning. And when you are building system, you may hit. Everything works perfectly. You have everything built. Everything is automated. Even the automation is automated. But there was just one tiny mistake in the system, and the user just couldn't use the system. So these kind of things you can learn as you go, as I do. So, and in the end, you have the system. Maybe you decided to go on AWS, and after you came up with all the diagrams and everything, you decided to use, let's say, the Lambda functions, and you come up with your role, and you automate this. But even though this works, let's say, can you do this again? So the problem is, you started to design it, and then you challenge yourself, you ask questions, you maybe consult with your coworkers. It was fun. You even built the pipelines and everything. But if you were asked to do another design, you will be able to do it from scratch. Basically, when you do those design steps, when you took those steps, do you know why you took each those steps? Because you just couldn't find an answer, you challenged yourself. So basically, it was not maybe a luck, but there was no any sort of like a roadmap for you. You just figure things out as you do. And I think that's not sustainable, because it's not testable, and you cannot, I guess, easily replicate. And you cannot even tell someone like how you do this. So you cannot even like share this knowledge easily, because it's just your own experience. That's why I am suggesting a framework. Not this one necessarily, but the framework works at your work, in your company, specifically maybe for your customer needs, based on what you are building. For instance, we can come up with the requirements early on. And when I say requirements, I am actually distinguishing two distinct requirements. One is functional, the second one non-functional. What functional means? Basically the features. If you go back to URL shortener, what the user's clients will do, shorten the URL, and then retrieve the shortened URL, then they forward it to the original site. Non-functional requirements, here we are talking about the quality of the system. You can also talk about like some theorems maybe, like you wanna prioritize read over write. Maybe whole system should work like this way, or in some parts, some different modules, you may need to prioritize write or read over write. But overall, you just need to ask this question at early on, like, overall, when you look at the system, do I see the read over write or vice versa? So you can make decisions over here. After that, you can start to talk about your entities, but these are not the necessary things you must have at the database. It's not that you need to have everything actually database. It just gives you an idea, because these are like a core entities, a must. Like if you have a user, if there's a login registration, yes, you definitely have the user at the database, but there could be some other entities that you might need. And this is the part you need to actually think about this briefly, like what I might be storing in the database. After that, you can talk about your integration, and you already talk about, you already like written down your requirements, and then you have the entities, and you can talk about your integration. Like you can come up with your data, you can come up with your how the API may work, for instance. And after that, you can do deep dive, you can start designing the system, and then you can enhance the system later on. But there is one more catch. Because what we do here so far is just technical things, and we all are happy with that. We can discuss, we can have a call, we can enhance the system. But what if after you build the system, it will be sold and there will be sales, or there will be an SLA, and which means there will be some objects, you have some goals. So you cannot have latency, or you need to be able to actually respond to your clients and customers. So basically you are building a product. And what product means, what value it brings, what value it has is actually what it delivers. So you need to be able to answer and ask these questions, what it does and whether it does well, and how long it takes to actually get it to market. So these are maybe not necessarily apply to us, or maybe DevOps engineers or platform engineers. This could be related to more maybe SRE or the FinOps. But at some point, there will be a discussion about, well, the cost, which is why what I am suggesting, instead of starting to actually design the system like on the whiteboard, okay, we can have the users, we can have the database, even a simplistic way. Actually, I'm going to contradict myself a little bit. Actually, don't do that. Try to understand, yes, the requirements, but in a way that like you can share and you can talk about this, like what the system will do. For example, user will create an account for a purpose, like they will log in and register, but try to draw that, like what is the purpose of the system, what it delivers. And in addition to that, you can also come up with the non-functional requirements, like, okay, we're gonna build this system. These are the 5 things we definitely must have, because that's the like a purpose of this product. But aside from that, we need to have this level of quality. So this system should deliver this and at this quality. So now you have it. You have it, but this is actually just the beginning, because right after this one, now you need to be able to actually make this estimation. Well, estimations kinda, is a lie. Maybe we actually joke around that we say the guesstimation, because usually, you were asked to build system, and how long it will take? 2 days. So the project manager jokes about it. Okay, next year will be done. So, well, this is the part you don't joke about it, because if you joke about it, and if you don't get this calculation right, and when you have the SLA, there could be maybe some consequences from financial level. So try to, not maybe 100%, but come up with something like a logical, something that makes sense. Like you have the system, how many requests do you think will be made to this system? And whether you will be able to, support the system. In other words, maybe client may have some ideas, come to you and tell you things, and you can tell it, yeah, it is feasible or not. At least you can play with the numbers a little bit and see whether it is realistic or not. So in other words, why you need this? Because if some person challenges you, a project manager or someone else, like, does it make sense? Yes, here's the number. This makes sense. This system is feasible. We can actually do something like that. There are many protocols out there you use. So you got to choose wisely, right? And this is just not like I am prioritizing them, just to bring your attention. So you are not going to choose anything random. You will know what you need to choose before you started building the system. And one thing I suggest actually, and if you are using like a building an API, I think it should always be done, is the versioning. And don't forget having the bare minimum security there. And this is the fun part. So we all know how the security is like undoubtedly important, but yet we have so many problems. We may sometimes maybe not prioritize, forget things like, the regular updates. Well, flash news, all the systems out there seems to have some vulnerabilities, and day by day we are actually being informed about the new vulnerabilities found. So, well, trust but verify, guys. Like if you are using a system, open source, third party, paid, doesn't matter. Keep up with the updates, because there are other groups, maybe some hacker groups. They are also looking for these patches and updates and try to find maybe systems like maybe the banks and the companies try to use old-fashioned way like a SQL injection and to hack the system. So it will be kind of surprising, but still there are cases that I read a couple of years ago, and the hacker group used SQL injection, but they spent a couple of years, by the way, to do that. However, the reason it happened because the company didn't do the patches. So these things happens. One thing actually also I can remind you and bring your attention at that, the zero trust. This is something I guess we can associate it with the network policies. Even though you have the system, you have everything up and running. Let's say you have the Kubernetes cluster, it's cold, secure, no one can access the secrets, whatever. But if somehow one workload, one part compromised, it will better to actually not allow anything than it should be allowed to do. So in other words, you can restrict all the communication as how it's supposed to be. Like that part should be send requests or connected to another part where the database may be up and running, or not. So you can use policies like a Cilium or maybe what else I can remember. Okay, Cilium, the only one I remember right now. Fail secure. So this is actually kind of fun one. What does this mean to me, actually, at least? If you cannot verify, consider this is not secure. So what does this mean? Let's say two microservices actually talking to each other, and one microservice couldn't actually respond to another one because there's a timeout. So microservice A knows that B got timeout. But it doesn't mean that there was actually no verification. Like a user maybe is already authenticated and authorized to do that things, but some reason there is a timeout. So that means you couldn't verify. So you are not going to continue with what the operation is being, you are not going to with that operation. You can just say, no, you are not letting actually move further from that point. Defense in depth is actually, I guess, the well-known one. Basically, you can have the API, you can have the middleware there, you can have the, classic authentication, authorization, and then maybe you can check the tokens time to time. So more you go deep in the system, different level securities you can apply. It could be the permissions checks, for instance, after user authenticated and authorized. There are so much information out there actually about the security. There are already some guidelines. So I'm not going to get into and explain them to you because you might already know, but I just wanted to remind you, go check them and try to know them by heart maybe in some degree, but at least when you are building a system, look at them. So subconsciously maybe you are trying to follow those guidelines. When it comes to also, outlining the fundamental components, you might need to, for example, have the load balancer application layer. So you can have these discussions after, you do the estimation, you come up with your functional and non-functional requirements. So you know that what system will do, what the product will deliver, the quality, and you are already come up with like a, how your API looks like. That means you will have an API. And based on that, this system will deliver this. And I think I need to have this type of database. I need maybe, consistent hashing. I need to use definitely CDN. Maybe I need to use this technology or that one, Redis, or maybe over another caching system. So basically, you will have this discussion and you will choose what serves you. Maybe you will choose load balancer, but like AWS, I guess, there are multiple of them. Which one actually serves you better? And there are, as I mentioned, there are various different actually solutions and services in terms of the databases and the caching. So maybe SQLite will help you to have your project delivered. I mean, actually, I use SQLite on local when I'm writing test cases, for example, especially when I was doing PHP tasks. And the funny thing is that though, when I use SQLite, all the tests passed, but when I deploy, they didn't actually, because the SQLite doesn't support all the queries that the MySQL. So these things, maybe it's one tiny thing, but when you are choosing these databases, know that if you are using some light version on your local, on some another environment, like a prior to actually promote the actual system to the production, we show that like everything will still work. So when you are actually extending the system, this is the part you may talk about now, the observability, right? Because you have now the idea. It's not like that much abstract anymore. You're going to use the API, you're going to do the versioning, you're going to have maybe the Redis, and you're going to have it actually on AWS, let's say, or maybe another provider. But that's not that much enough, because if you go back and talk about the SLAs and other things, also from technical perspective, because delivering a system is just the beginning, because there will be some failures. And then you need to now think about that, why this is happening. Yeah, you don't know, because you are not observing the system. You haven't implemented anything. Fortunately, we do this, and then we have the observability. But when we are doing this, you need to understand what you are delivering and how the system will behave in some degree, because observability basically means try to figure it out why system is doing it. It's not like there are predefined metrics always. There is something unknown, and you are trying to figure it out, but using the logging tracing and the logs traces and the metrics. So which is why don't skip that part and try to actually have that observability implemented. So everything's here that so far I said can be categorized under these three pillars. In fact, what I will suggest you, if you are starting to doing the system design, again, I'm going to contradict myself one more time. Don't start actually from the designing the system on the paper or the whiteboard, or don't start actually even talking about the previous framework, which we call README. Understand these three pillars first. Why? Because you must have the terminology. Like if you don't know if you don't have the vocabulary, then how are we going to ask those questions? And if you are not familiar with how the systems are built, then you won't be able to even actually, draw something there, because you will have the users, the server and the backend, and then you won't be able to challenge that design. You won't be able to actually decouple that system, because maybe you have never heard of the caches. There is no cache system in your mind. And then how are you going to actually have that system? You will get stuck when you are designing it. So basically, these are the fundamentals actually we must have prior to designing the system. And it will be better to be familiar with that, learn about that. And after that, it will be much easier for you. Not like it's going to be so smooth process, because you need to recall them. But I think it will help you a lot if you are designing the system for the first time. So these are just the highlights. You have everything done, but it's not enough. Why? Because you may forget a couple more things. Let's say you may have a single point of failures, like, you have a DNS server and you have only one DNS server, and then it's done and everything is gone. So I think a couple weeks ago or months ago, Cloudflare decided to not to have resolve the DNSs just for fun. I mean, AWS also didn't work for some reason. We didn't have an internet on the planet. So yeah, it may happen. So we are also relying on too much, maybe a third-party system, because we cannot build them. But at least be sure that like you have some replicas or you have some redundancy. You know that, for example, what will happen if one of those systems fails, or vice versa. Let's say you need to route the traffic from one CDN to another CDN. So you need to also maybe deal with the DNSs, and you need to maybe inform your clients. So you will not deal with some other problems later on from maybe like client perspective or financial perspective, because there will be maybe a downtime. At least you can also be aware of this, so you are not going to be surprised. Yes, you cannot have actually everything. You just need to make that decision. Well, I don't know whether it is possible. So far, what I learned, it's not possible to have everything. And I think you just need, because the systems, like the products, are somehow like also, living things. Like they are shaped and then they are serving a purpose. So that's kind of makes sense. So it's there and it's doing some certain things based on the requirements. So it makes sense that it cannot have everything. So these are the things that you need to align in advance and be aware of that, like what we are prioritizing, what is important for you. Like you need to go after, let's say, the eventual consistency, or it is 100%, no, you're going to go strong consistency. And I think it is important to have this discussion first, early on. And also, if you know it and if you defend the idea, it will be better to have your system built, not easily maybe, but it can be documented, because it's not just like a by mouth, like we built a system like this way. Why? Because we are prioritizing on our system actually the strong consistency, but some other parts in the system, yeah, may have actually maybe weak or eventual consistency. Things will fail, as we briefly touch, so be aware of that, but it's not just like, okay, things will fail. No, things may fail, but you can build the system in some degree, actually tolerate that, because you kind of know what may fail. What may fail, like timeouts, or this makes die. And you know that, okay, this makes die, but we can get like a really good one. No, you don't necessarily need a really good one, because what do you mean really good one? Like an expensive one? No. You know, how often actually things will be written the disks. So you can have these discussions. Based on that, you can choose the proper one with some backups and redundancy. And I think it will actually not necessarily postpone, but it will have the system resilient. So let's say you build a system, it's a messaging service, right? And everything is fine. It's public, everybody is using it. And time to time, like, during the maybe New Year or so, there is a little bit peak, because many more people are using the system. They are shopping, they are just, texting, using the system. And then somehow one famous person decided to use that system and tweet about that. And suddenly millions of users are actually using the system. So know your bottlenecks, because maybe your system works well. You tested it, you tried to crash it, you did disaster recovery, everything, but you didn't think about something that, okay, we tried to use the system, this number of users, and we actually try to crash this system, pretending like there are so many users, but you realize that there can be much more users. You never think about that. So know your bottlenecks in the system, where it can have, where you may have these problems. Hardware level and the software level, you may have these problems, and if you know them, then you may have to place the observability. So let's say it's not fun, but 2 a.m. in the morning, you will get an incident call, and you realize that, oh, okay, because we have some issue, CPU maxing out, but that's not an issue. What happened? Because another node is dead now, but that's okay, because now there is so much operation happening on this another node, because now this node becomes the primary, and because it needs to get all the data from there, even though temporarily, then we see that, okay, CPU is here a little bit like maxing out, but that's fine. You can say that, because you know why it's happening, because you have the observability, and because you know your bottlenecks. Well, if you haven't gotten anything from this presentation, and if you already got bored because I've already telling you the things you already know by heart, at least maybe 2 things you can get. These 2 books. And Designing Data Incentive Application will, I guess, have one more now, the new version. So I'm waiting for it. And the System Design Interview is kind of cool one. It is more like an easy way to start actual system design. I suggest to, if you want to get into it, the first volume 1 and volume 2. And after that, you can actually get into the designing data intensive. It's more technical. It's 2 deep dives. It's talk about like a consistent hashing and all other things still we must know. But I think these are the 2 things. These are the 2 books, at least 2, 3 books, I think we must have in our libraries. Thank you. Ready? Stop sharing. I will. It worked.
So there's no question on slide, huh? I see that you enjoy it. Okay, but maybe there is some question
No.
here. No.
You insisted.
Thank you for a very nice talk. I have a question for you. How to present all these ideas and stuff to the, I don't know, product people?
Yeah. One of the slides actually kinda meant for this. The framework called README is kinda meant for that, because that's the estimation part comes in. Because you need to define your system, the idea. The client may tell we have a system secure, and you need to tell the client there is no system is secure. So that's not gonna work, right? You need to have the numbers and try to not to convince the client, but be realistic. Usually, fortunately, I am not the person who talks with the client, and I guess I have never done it, and hopefully I will never do. I just don't understand. I think you have the same problem. You need to have the two things: what this system will do, and what deliver, and what quality you will have. And if you have them written down, I think that may help in some degree. It's not like there is a bulletproof solution, but it's, I guess, much better than just to have the technical conversation deeply. That's how I can handle. I mean, guess. Good. Thank you.
Any other question? Next one.
Thank you for presentation. In which case you are strongly not recommended to create your own system?
In which case? I am running a home lab, and I am using OpenVRT, for example, as a router. It's open source, and I'm playing around. I kick myself from my home network multiple times for now. So if I am delivering a product, well, if I am not able to, if I am going to sign an SLA with the client, for instance, I will rather not to use anything I build, but use third-party systems, because they will have SLA with me too. So if you can keep your promises on the paper, I think you can go. That's how I think.
So last question. No. Okay. So that's it. Thank you, Emrah.